In the previous lecture, we looked at kind of introduction to the topic of engineering economics. In this lecture, we're going to be looking at cash flow diagrams, which is just a convenient way of representing cash flow from complicated projects, which may have outlays and benefits that are accrued over an extended period. So let's get right into it. Um, there's, as I said, graphic method of displaying project costs and benefits. You'll see what I mean in a minute. There is this thing called the year-end convention, in which revenue costs and or costs are shown as occurring at the end of a year. So we're going to be creating these cash flow diagrams where you have time on the horizontal axis, and then we're going to put the costs and the revenue at the end of those. The exception is typically the initial design construction, which may get all lumped into the beginning of year one or end of year zero. And I'll show you in a minute what I mean by that. Okay, so there's four types of cash flows that are typically shown in cash flow diagrams. You may have an initial expense, usually an expense. That might be for design and construction. You have annual, and usually this is a uniform annual series. So you'll have the same amount over an extended period. It may be like benefits. Maybe the benefits are uniform over an extended period. So that might be represented using annual. Gradient. A gradient is essentially, in this case, it's an arithmetic gradient. In other words, it's going to be going up by a constant value at each of the time periods. And usually, or the way it's represented, the gradient series in year one is going to be 0, and then the next year it's going to be incremented by some amount, and then incremented again in the following year. Lastly, we have future 1-year costs and benefits. So that might be like salvage value. That might be at the end of your project life, or maybe there's some other major rehab, for example, that you may want to attribute to a particular year of the project life. All right, so in this case, we're going to look at initial costs. So you can see we have the years across, going from 0 to 6. And costs are shown with a downward arrow. So this, and then with the value here, so 100K, that would be the initial cost is 100K, would be represented in this cash flow diagram. Now, what if you have future revenue in a particular year? So you might have just say future revenue year 3. Revenue is going to be shown by an upward arrow. In this case, it's 100K in year 3. And you see we're using that. If this is a continuous record, we're going to use the end of the year, essentially the end of year 3, to represent our future revenue. If we had a future expense in year 3, down arrow at that same location. All right, annual revenues, and this would be annual uniform revenues. In this case, 100K dollars, or $100,000 in years 1 to 6. So it's $100,000 per year, and it's represented using with an upward arrow at each of the years. And in this case, you see that all the arrows are the same height and all of the same value of 100K per year. Annual costs, so it's the same thing, but in this case we have downward arrows representing costs. Remember, down for costs, up for revenue. A gradient, so here's our gradient. You see in year 1, 0. In gradient year 2, our gradient series takes on a value of 20K. In this case, because it's increasing by 20K, that obviously is going to be dependent on your series that you're representing. Year 2 increased by another 20, another 20 in year 4, and another 20 in year 5, and then finally another 20 in year 6. So it's a revenue that's increasing over time. This could also be, and as frequently the case, maintenance, which increases over time. So you may have a gradient cost You have a down, there it is, downward arrows. Sometimes you'll have a situation where you have both an annual revenue and a gradient revenue. So in this case, you see the first year value, it's not 0, but in fact is 100. So essentially what we have is an annual cost of 100 in each year, and then we're adding to it a gradient revenue of 20K in years 1 to 6 as well. So that's why we have that 100, and then it jumps up to 120, 140, 160, 180, and then 200 in year 6. So in this case, you need to think about this as, although it looks, because it's just a single arrow, it looks like a single series. We're going to think of this as 2 series, one an annual uniform series and one a gradient series.